Hello friends, welcome again in Devrat Knowledge Villa, and you are watching our English video series of operating system and learning process management. Today we will discuss scheduler in terms of process management, but we will learn the scheduler with respect to state transition diagram. So if you are still remain to watch our previous video of state transition diagram, so please click on upper right corner I button and watch the video of state transition diagram, so you will be able to better understand the scheduler. In terms of scheduler, let's start with the types of scheduler. So totally there are three types of scheduler. It is long term scheduler, short term scheduler and medium term scheduler. So first let's start with the long term scheduler, where actually long term scheduler is working and how long term scheduler is working and what is the function of long term scheduler. So let's start. Long term scheduler is working here when process is arriving from new state to ready state. So long term scheduler is bringing the process from new state to ready state. It is the work of long term scheduler. So it is a long term planning because there are multiple processes are newly created inside the secondary memory. Whenever processes are going to be created, so it is going to be created inside the secondary memory, and whenever processes is arriving into the primary memory, so processes are arriving to execute. So it will become a process. Whenever a process was into the secondary memory, so it was a program. Get it? This thing we have already understood in our previous video. So whenever processes are arriving from new state to ready state, so it is going to be done by long term scheduler, and this thing is called as a degree of multi-programming. Why? Because here there were multiple processes inside the new states and all number of processes are arriving into the ready state. But whenever processes are arriving into the ready state, so not all the processes are going to be scheduled. Out of those number of processes, only one process will get the CPU, because at a time one processor can run one process only. Get it? So this thing is known as a degree of multi-programming. Second thing, our second type, that is short term scheduler. So short term scheduler is working over here in between to ready state to run state and run state to ready state. What is the role of short term scheduler? Whenever number of processes are available into the ready state, so out of one process, short term scheduler will select which process is going to be run out of this number of processes, and then after short term scheduler will call to the dispatcher, and dispatcher will allocate the CPU to that number of process, and process is going to be scheduled, and process will reach from ready state to run state. So if here is multiple number of processes inside the ready state, so out of those processes only one process is going to be scheduled, and that process will reach to the run state, and that process will get the CPU. That is the role of short term scheduler. And what again short term scheduler is doing, whenever one process is running and if any other processes are arriving with the higher priority, so short term scheduler will stop that process and again move back that process to the ready state, and it will execute to the higher priority process. Same thing look like time quantum. If time quantum of that process who is going to be run, if that process time quantum is over, so short term scheduler will move that process back into the ready state and bring new process for the running. So that is the role of short term scheduler, and this activity is known as a context switching. Whenever we are bringing the CPU from one process and going to allocate that CPU to some another process, this thing is known as a context switching. We are switching the CPU between one process to another process. So it is the role of short term scheduler, and this thing is known as a context switching. Then after third type of scheduler, that is medium term scheduler. So medium term scheduler is working here when there is a lack of memory inside the wait state or block state or into the ready state, because it is primary memory. Ready state, run state and wait or block state, these three states are available into the primary memory. whenever primary memory is going to be full and there is no more space to store the number of more processes into the ready state, as well as there is no more space to store the wait or block state. So there is need to pull some processes again from primary memory to secondary memory. Get it? Because we have a lot of space inside the secondary memory. So from ready state or from wait to block state, whenever there is a lack of space for the memory, so we will pull back to number of processes into secondary memory. Get it? And it is it is going to be happen by the medium term scheduler. So it is the role of a medium term scheduler, and this activity is known as a swapping. Same here, from ready state to suspend ready, this thing is known as a swapping of processes. So processes are moving from primary memory to secondary memory, and again if there is a space is going to be happen inside the ready state and wait state, so again processes are moving from secondary memory to primary memory. This thing is known as a swapping, and it is going to be carried out by medium term scheduler. So total there is 3 types of scheduler: long term scheduler, short term scheduler, and medium term scheduler. Now we will discuss types of scheduling. In terms of types of scheduling, we can say that it is process scheduling or CPU scheduling. Whenever you will refer multiple number of reference books, so somewhere you will found the word written like process scheduling, and somewhere you will found the word written like CPU scheduling. So both this thing is vice versa. Do not confuse in between process scheduling and CPU scheduling. Like first process P1 is process P1 will run, then after P2 will run, then after P5 will run, then after P7 will run. So we are scheduling the process. This thing is known as a process scheduling. Same thing, we are going to schedule the CPU. First CPU will be allocated to process P1, then CPU will be allocated to process P2, then CPU will be allocated to process P5, then CPU will be allocated to process P7. So this thing is known as a CPU scheduling. So don't be confused in between process scheduling and CPU scheduling. Both this thing is vice versa. 2 types of scheduling is there: preemptive scheduling and non-preemptive scheduling. In terms of preemptive scheduling, we will understand look like whenever we are going to stop any process due to the priority of higher priority process is arriving, or time quantum of regular process is going to be over and we are going to schedule some another process. This thing is known as a preemptive scheduling, because here we are going to stop some process and we are allowing to some another process to run. It means we are going to stop one process in between its execution. Like P1 is going to be executed, P1 is running, P1 is using the CPU. So in between the execution of P1 or before complete the entire execution of P1, we will stop P1 and we will allocate CPU to some other process like P2, P3 or P4. This thing is known as a preemptive scheduling. Second thing, there is a non-preemptive scheduling. Non-preemptive scheduling means we can't stop any process in between the execution. If we want to allocate CPU to some another process, so we have to wait till the completion of first process. Like P1 is going to be executed, so P1 is into the running state and P1 is using the CPU. So if we want to execute P3, P4 or P5 or P2, so we have to wait till the completion of P1's execution. If P1 is not going to complete its execution, so we can't allocate CPU to some other process. We have to wait till the completion of P1's execution. When P1 will complete its execution, then and then we can allocate CPU to some another processes. This thing is known as a non-preemptive mode. It means we can't stop any process in between the execution. Look like some activities like we want to sneeze, so we can't stop. Get it? Are you getting what I want to say? That we have to sneeze at least and look like we are hungry, so we have to eat something. We can't maintain our hungerness for long number of time. Look like we want to go washroom, so at least we have to go. So this thing is known as a non-preemptive mode. We can't stop any process in between the execution. This thing is non-preemptive, and we can stop any process in between the execution and we can allocate CPU to some another process. This thing is known as a preemptive scheduling. Next thing, processes. 2 types of processes over here: CPU bound processes and IO bound processes. What thing is happen for the CPU bound processes? whenever process is in execution, so process require CPU as well as process require IO. So in between the execution, somewhere process will go to use the IO devices. So this thing is known as a waiting time, and whenever process is in execution, so this thing is known as a burst time. I will explain you the parameters of process. At that time I will explain what is burst time and what is waiting time. So which process burst time is higher than the waiting time, so this thing is known as a CPU bound processes, and when there is a waiting time is greater than the CPU time or burst time, so it is known as a IO bound process. It means which process require the more number of time CPU, this process is known as a CPU bound process, and those number of process which require IO devices more number of time, this thing is known as a IO bound process. Look like process P1 requires CPU for 5 millisecond and require IO devices for 3 millisecond. So we can say that process P1 is a CPU bound process. Another process P2 is there. P2 requires CPU for 2 millisecond and P2 require IO devices for 6 millisecond. So P2 using CPU for 2 millisecond only and using IO devices for the 6 millisecond. So we can say that process P2 is a IO bound processes. It means it is using the IO devices more number of time. These processes are known as IO bound processes. And which processes are using more number of time CPU, these processes are known as a CPU bound processes. So whatever the long term scheduler is bringing the number of process from new state to ready state, so it is bringing the mixed process of CPU bound and IO bound. If short term long term scheduler will bring the all the processes CPU bound, so CPU will be in waiting again and again process will go for the waiting. If scheduler will bring the only IO bound processes here into the ready state, so CPU becomes free always, all the processes will go for the IO. Get it? So inside the ready state both types of processes require, some of the processes are CPU bound and some of the processes are IO bound. Hope you are understanding well types of scheduler, types of scheduling and types of process. So in next session we will continue the CPU scheduling. Till today we are learning process management. Right now we are moving from process management to CPU scheduling. So please wait that time when I am reaching again with the videos of CPU scheduling. Thanks for watching Devrat Knowledge Villa.